Hi there, in this video I want to talk about CatDat. This is a web application which is a comprehensive database of categories and their properties. And in this video I want to present to you what this is about, how you can use it, and also how you can contribute to it. So categories are the main building blocks of category theory, and in this video I will assume that you know what this branch of mathematics is about, because otherwise you won't be able to follow, I'm afraid. So here you have the main features on the homepage. Of course, everything can change in the future. In this video, I want to talk about the present state of the application. So here you have a list of categories which are registered in the database. As you can see, there are quite a lot, but of course it could be more, and it's still evolving. So I hope that we can grow this database over time. Let's have a look at the first example, the category of abelian groups. So on each category detail page, you have first of all the list of tags. There you get the list of categories tagged with this tag, and you have a notation in LaTeX. Then you have the objects and the morphisms. So this defines the category, so to speak. Then you have the list of related categories, if any. For example, the category of groups. You can also go back here, and here you have an nlab link. So nlab is this awesome Wikipedia about category theory, and this is more textbook style, I would say. And CatDat doesn't want to replace the nlab, that's very important, but it builds on it in some way. It's more database focused, but I will explain exactly what this means. Then you have a short description, and then this is the heart of the application. You have a list of properties and non-properties. So for example, the category of abelian groups is abelian, finitary, algebraic, and locally small. And not only that, you can click here and see the proofs of these claims. In this case, the proofs are very easy, so they're also very short, right? And you have also a couple of non-properties. For example, it's not skeletal and it's not split abelian. And sometimes here I write down the proof, and sometimes I write down just a reference to a book. But I also have a deduction system here. So this means for example, the property of being abelian, I can automatically deduce that it is additive. And I can also deduce that it has finite products and binary products, of course, then as well, and also a terminal object. And it's connected because it has a terminal object, etc. So you can make a lot of deductions. All of them here are really deducible from these three properties. And similarly for the non-properties, you can deduce a lot of non-properties. For example, it's not trivial because a trivial category is split abelian, but we already saw that it is not split abelian. So of course you can also just prove it directly here that it's not trivial, the category of abelian groups. But the point is that it's a redundant non-property. And the goal is to have as few properties and non-properties as possible to deduce all the rest of these properties. And these proofs here are generated automatically. I didn't write any of these. I just wrote the general structure and the logic behind it. So these are the properties and non-properties, and then you can scroll down and see, oh, the category of abelian groups has no unknown properties, which is nice. So every property in this database is either true or not true for the category of abelian groups. And then we have the list of special morphisms. So for example, isomorphisms, monomorphisms, and epimorphisms. Maybe we can also add regular monomorphisms, etc. later. And for the descriptions, I have also added the proofs in case it's not obvious. Sometimes it's obvious, so sometimes I also add references there to books or posts. So this is the category detail page. And in case you don't know any of these properties, you can just click on them. For example, what is a split abelian category? Let's click on it. And then you have a property detail page. You can also access it from here. So this is the property list page. There you can also search. And then you can find the properties. So you have a short definition of the property. In case it's available, you also have the dual property. In this case, it's even self-dual. This is not always the case. For example, let's take equalizers. So the dual property is having co-equalizers, right? So let's go back. And you have the list of related properties, if any, and you have an nlab link. So again, I don't want to replace the nlab, but it's just in case you want to learn more about this property, about examples, lemmas, etc. This is what the nlab is still for. Then you have a list of relevant implications. For example, every split abelian category is abelian. This is trivial. And every trivial category is split abelian. Well, this is also not very interesting. We will have a look at a more interesting one. Let's have a look at the complete categories. So for example, let's have a look at this one here. Every complete category has equalizers and products. So this is a well-known theorem in category theory, and it's actually an equivalence. And this deduction system, of course, uses this. So for example, if you have a category and you add the info that it has equalizers and products, CatDat automatically deduces that it is complete. And also vice versa. So for example, if you know that a category doesn't have equalizers, well, it cannot be complete. So this is also what's used here automatically. And then you have kind of the opposite of what we had before. So in this case, we have all the categories which satisfy this property and all the categories which do not satisfy this property. In some cases, also unknown. So for example, let's go to a more niche property. Let's go to locally presentable. For example, I don't know yet that the category of local union spaces is locally presented. It's very likely that it is not, but I don't have the proof yet. So this is why it's also here listed as unknown property on the category detail page. And these implications here are listed on this dedicated page. You can also search, for example, I want to have implications which involve equalizers. Then you can find them, or groupoids, or abelian categories, or toppers. And this is just the beginning. Currently I have 96 implications, but you can imagine there are thousands which we could add here. And I hope that we as a community can add them here in this database style. For example, here, the first one is actually the definition of an abelian category. It's an additive category with co-equalizers, equalizers, which is epiregular and monoregular. In case you forgot, you can just click on this property and see its definition again. All these implications here, as I mentioned, are powering the deduction system. And not only that, we can automatically dualize them in case the properties are dualizable. For example, here, that the category is complete if it has equalizers and products, it's automatically deduced that a category is co-complete if and only if it has co-equalizers and co-products. And you can see these dualized implications by clicking the button here below. And then you can now find this here. So now we have this implication here. It has been added automatically, and it's also used on the category detail pages here. And also kind of minor addition, but also useful. So for example, you have a lot of self-dual implications. So for example, if you have a category which is self-dual, meaning it's equivalent to its own dual, and has some other property, then it has the dual property if available. So these implications here are added as well. Okay, and next I want to talk about the comparison feature. You find it here. And here you can add up to 10 categories and compare their properties with each other, which is very nice. For example, sometimes you think categories are very similar, but maybe they're not, and you can just check it here. For example, here you can compare the category of abelian groups, let's add it, with the category of commutative monoids. Okay, and then click on compare. By the way, this whole application is usable with keyboard. You don't need a mouse. You can click on it, and then you get a comparison table. So you see that lots of properties are the same, but in some cases, and I've highlighted these, they are different. For example, the category of abelian groups, it's abelian, additive, and hence also balanced, but the category of monoids has neither of these properties. In case of the cogenerator, well, I don't know yet if it has a cogenerator, probably not, but yeah, so looking for the proof. Epiregular is different, but you see most of the properties are very similar. we can add up to 10 categories. We could also add the category of, let's say, finite sets. Why not? And then you have 3 categories which you compare here. Maybe for these finite sets, it's more interesting to compare the category of sets with the category of finite sets. There you actually see a lot of differences. So this is the compare feature in a nutshell. And the next feature I want to talk about is the search feature. So on this page, you can do a property combo search. So you can look for categories which have some properties while not having some other properties. For example, you could look for an abelian category which is not complete. So I expect to see the category of finite abelian groups now. And indeed, I get it here. Also, finitely generated groups is an example. And in this case, all of these properties have a dual, so you can just dualize the search to find maybe even more. Well, in this case, the same categories satisfy the search here, but it's not always the case. So for example, if I look for a complete category, which is not complete, in this case, the database doesn't have a record, but I can dualize the search. So look for a category which is complete but not complete, and I have it here, exactly one result currently. Maybe we find more as a community, the partial order of ordinal numbers. Yeah, this has no terminal object. You also have the reason here, so it's not complete. And you can add as many properties as you like. For example, I look for a category which with pushouts, with equalizers, but which is not small. Let's say like this. And you can find, of course, many examples here. What happens if I say I want to look for a category with products, but doesn't have a terminal object? This doesn't make any sense, right? And the search actually recognizes this using the deduction system I've talked about. Namely, every category with products automatically has a terminal object. So of course there won't be any search results even if we add more categories to the database. So we have this mentioning here, no categories found because the requirements are inconsistent. And I can also dualize it, but of course it's also inconsistent then. Okay, and then I want to finish with some minor remarks. For example, here on the settings page, you have the option to switch to light theme if you prefer this. It's actually taking your system defaults as a first theme. This is why you saw the dark theme on my screen, but when you open it, you might see the light theme straight away. And here, this is the category detail level. So this means how do we see the properties on the category detail page. So for example, when I click on merge, what happens is when you click on the category of abelian sheaves, for example, you see all the properties here and you don't have any distinction anymore which of these are deduced or already in the database. So click this if you just don't care if it's deduced or not. And here, basic, this is kind of the opposite. So there you only have the properties which are in the database. And this is why I also write here further properties can be deduced. So when you are not interested in all the properties, you can click basic, but all is the default. And I think it's also the best option here. So you have a distinction between properties which are directly saved in the database and those which are deduced. And by the way, this whole application can also be used on your phone. So everything is designed in a responsive way here. For example, you have this hamburger menu here. You can search for properties, click on these, scroll through the pages, scroll through the examples. Even the comparison works here. So you don't need to be on desktop to use CatDat. But as you saw, some of these things are missing. For example, let's go to the category of locally reading spaces. Here I have some reasons not already given, but also a lot of unknown properties. I also wrote a comment here. So as a community, I hope that we can fill these gaps and not only fill the gaps to the existing categories, but also add new categories, add new properties, add new implications. Maybe some implications are missing even between these properties I wrote here. It's possible, right? And yeah, To record these, I've written this Excel page about missing data. So here you have the categories with unknown properties, the categories where a property is known but doesn't have a reason yet, and same with non-properties. And here we have categories where the special morphisms, so iso, AP, or monomorphisms, are currently unknown. So for example, the category of schemes, I don't know what the apomorphisms are. Probably they're also not so easy to determine, but for the category of manifolds, maybe it's doable. But yeah, currently the database has an answer. And here the missing combinations. So for example, maybe there's a category which is complete, but doesn't have a generator. I mean, it's consistent in the sense that there's no contradiction here between these two properties. This is also checked by the deduction system. This is actually possible theoretically, but currently the database doesn't have an example for this combination. So the search for this combination here would give you 0 results, but in theory it could give you some results. So all these combinations are listed here. Also some weird combinations, for example, in the Boolean category, which is not locally small. So that's not very useful, I would say. But in some cases, it's interesting. For example, a co-complete category which doesn't have pullbacks. This is interesting, right? Currently, the database doesn't have it. Also, the dual is not registered right now. So in case you want to contribute, I'm very happy because this is really a community project. And as of recording this, there are actually 3 options. So the first one is a Google form I've made. So you can first decide if you want to add a new category, for example. You have to write down your email address. And then you want to include the name, the description, etc. Which properties does this category have, which non-properties, and then you can submit it. And in the same way, you can also add new implications, add missing data. Something is wrong, you can also report it here. And also if you have an idea for a new feature, for example, if you want to record also the regular monomorphisms, this would be a feature. Or if you have an idea how to improve the design, yeah, then this is the way to go. Then you click, I have an idea for a new feature. So this is the first option, and this has the advantage that it's very low level. You don't need to have any knowledge about coding or GitHub, but the second and third option do require knowledge about GitHub and coding. Namely, all of this here is open source. It's a GitHub repository. Here you can also find more about the information about the tech stack, about similar projects, and also how to set up the project locally. And if you want to contribute, you can click here on contributing. There you have the contribution guidelines and also detailed instructions what to do. For example, when you create a pull request, you follow these instructions to set up the project locally. I won't get into details how to do this now because this might change in the future and I don't want to make this video outdated right away. So just read this documentation. It will always be up to date. And then you have detailed instructions how to edit the database. And also we have some guidelines here. For example, when a new category is added, please add also the properties and the non-properties. So I won't go much into detail about the technology of this web application, but I want to mention 2 things. First of all, this is a SvelteKit application. And secondly, the database is a SQLite database currently, and it's defined in this database subfolder here. First, we have the migrations, which basically define the table structures. For example, here we have the table of categories, table of related categories. And actually, I have a diagram as well. For example, when you go to database.md, here you have a diagram of the whole database as of recording this. So, for example, the categories, related categories. We have the category properties, non-properties. They are of course connected to the category of properties, to the table of properties. They are prefixes. Maybe you saw it already, but when I say, for example, that the category of commutative monoids is finitary algebraic, I don't say it has finitary algebraic. So we have to save these prefixes as well. And also the implications are here registered as a table connected to the properties via assumptions and conclusions. So this is the rough structure, and these tables are all defined in this migrations folder here. And if you want to contribute, usually it's not here, it's in the data subfolder. And here we have all the data which is being displayed in the applications. For example, here, categories.sql. Here we have all the categories in the database. But only the basic info, right? Not all the properties. These are in different files. For example, here we have the category of schemes. We have the notation, the objects, and the morphisms. Or here we have the category of sheaves. We have the objects, the morphisms, also a description, also the nlab link, because it's available. In some cases it's not available, then we put null here. Yeah, then we have other files, for example, let's say properties.sql. So this defines all the properties. For example, what is a complete category? This is the definition. We have an nlab link, and the dual property is co-complete. And it's also invariant under equivalences. So this is also something I save. So for example, here, when I go to, let's say, finite, I have a warning here for all these properties which are not invariant under equivalences, which is kind of bad, right? So this is something you don't want to have. So I add this warning here. So this is what these booleans here are signifying. For example, when you want to add a new property, you just edit this file here in your pull request. You can also edit the existing descriptions, for example, if there is a typo or if you have a better reference, etc. Then this is the next important file, category properties. So this associates a property with a category. For example, here we have the information that the category of sets is locally small. And we also have the reason, which is in this case very easy, of course, but in some cases the proof is not so easy. So I actually wrote down some LaTeX here as well with the proof. In some case, you also need to just reference a book or some article. For example, here the information that the category of manifolds is Cauchy complete. It's actually a small theorem which is at this nlab page. So you can also add HTML here, actually in these reasons. And as you saw, you can also add LaTeX here. Okay, and same with the non-properties. So these are here. For example, the category of groups doesn't have a sub-object classifier. This is what we saw before. And here you have the proof for it. What else? Yeah, for example, the isomorphism descriptions here. But very important, implications.sql. So this defines all the implications which in turn empower this deduction system. For example, every locally finitely presentable category is also locally presentable, or every additive category is pre-additive and has finite products. And actually this is an equivalence, so this is why we put true here. Or every additive category has disjoint finite coproducts. So this is what we save here, all these implications. And these deductions here are all done via scripts. In this case, deduce properties, for example. Yeah, and this is some TypeScript code which tries to deduce new properties from given properties using the implications. I won't go into the tech here. This video is mainly about how to use this. So when you want to find certain categories which have some properties but not some other properties, this is the way to go. I think there's no place like this. I mean, before you probably had to find something on your own or just ask a question on Math Overflow or Math Stack Exchange, but now you can just look here. But that's pretty much it. I'm excited to see your contributions, but now let me get back to coding.